What is a zero? There's all kinds of names for it. It's the same thing as a what? A donut. I wish. Be a good way to work that into math, wouldn't it?
Well, the x zeros would be the solutions.
The solutions, yes. So zeros are solutions, which are also the x-intercepts, right? Isn't that what you were saying?
Do we have to find the y-intercept?
No, you know what? Y-intercepts aren't nearly as important as x-intercepts because the x-intercepts are the solutions. All they want us to do is find the zeros and then tell the multiplicity of them. Multiplicity is how many times they occur, okay? So if you have, let's say you have, let's work through 29. Let's kind of go through this one first. And we'll say, well, okay, let's work one of these all the way through and see what they're asking us here. T cubed minus 4t squared plus 4t. If you want to solve, if you know that you're looking for the zeros, that's the same thing as the solutions. It's the same thing as the x-intercepts. The x-intercepts are where y is 0, so sometimes that might help you. The only reason the y equals 0 would help you here is if I go in and I set y equals 0, I'm basically trying to solve this equation, okay? What ways do we know to solve equations? That's really what we kind of got to get at here. We always are happy if they factor, right? If they don't factor, then we've got to use something else. If it's a quadratic equation, we can use the quadratic formula, but this isn't a quadratic equation, at least not right now, is it? One of the big ideas in math is how do you break something down to a lesser degree than you have? Factoring is always the best way. I don't know if y'all remember this. We can do long division. Do you remember doing that back in Algebra 2? There was long division, and then we had something called synthetic division. Do you remember that? Do you remember that term, synthetic division? You remember hearing it before anyway, even if you don't remember how to do it? So we're going to be reviewing that in this section too. We don't want to do long division or synthetic division unless we have to, okay? Because it's you know, there's a lot to remember there. Can we factor this? Mm-hmm. What are you thinking, Kate? Do you see something we could do first?
I was trying to. I got t squared minus 2t multiplied by t minus 2.
Okay, let's see what happens.
Oh, no, wait, no.
No, you're on the right track. Do you remember that when you factor, the first thing you should look for is to pull out the greatest common factor? And that'll make your life a lot easier. Because you may have it right, and I'm just not thinking that way because I have to do it in littler pieces, okay? So you may have the same thing. We'll check when we get done. Isn't there a t in each one of these terms? So let's take the t out first. So it's t times t squared minus 4t plus 4, right? So what we're hoping is, okay, we got one factor as a t. That's good. That means t is 0 is one solution. We'll write that down in a minute. What I'm hoping is this t squared minus 4t plus 4 factors. What multiplies, bless you, I'm going to use this little organizer just to kind of remind you that you could use it if you wanted to. What multiplies to give me 4 and at the same time adds up to give me negative 4, that number in the middle? Can you think of something that multiplies to give you positive 4 and adds to give you negative 4? I didn't take it out yet this morning. How about negative 2 and negative 2? Would that work?
Yes.
Okay. So let's try that. It looks like this would factor if we chose negative 2 times negative 2. Negative 2 times negative 2 is 4. Negative 2 plus negative 2 is negative 4. So it would be t minus 2 times t minus 2. Did you have t minus 2 times t squared minus 2t? Is that what you said?
Yeah.
That's good. You figured it out without doing the GCF. You figured out how to factor it without taking the GCF out. Sometimes it's easier just to take that bigger factor out. And you're left with something that most of the time your brain can break down easier, but if you can get it before, you would just need to take a t out of your t squared minus 2t. Because if you think about it, if all these things multiply to give me 0, can I find my answer by saying, well, maybe t is 0? That's one factor. And the other factors are t minus 2. I only really need to set it equal to 0 once. One of my zeros is t equals 0. The other one is going to be t minus 2 equals 0 gives me 2. Now, in the multiplicity part that they asked me about, that t only occurred as a factor one time, didn't it? So this has a multiplicity of 1 because it was only a factor one time. But the t minus 2 was a factor how many times? Twice, right? It was 1. It was the same factor in there twice. As a matter of fact, couldn't I have written this as t times t minus 2 squared? Couldn't I have written it that way also once I factored it? That exponent right there, that tells me the multiplicity. That's another way you can get it, is to rewrite it. So 2 has a multiplicity of 2 because it came from the factor. The factor that gave me t equal 2 was in the equation twice. So it has a multiplicity of 2.